She was the largest ship ever built. And yet her maiden voyage would be her last. After RMS Titanic struck an iceberg, 1,500 men, women and children drowned, sending shockwaves around the globe and starting a debate that still rages today. Why did she steam at full speed into an ice field? And why did a supposedly unsinkable ship sink so suddenly? Now, an album of photographs that lay undiscovered in an attic for over 100 years has come to light. An album that charts the Titanic's brief life. But these photographs aren't just a unique window onto an historic moment. There's something else.
I kept turning the pages, and I wasn't really quite prepared for what I was about to see, because as I turned to this section, I spotted what I thought was a very strange mark on Titanic's hull, and it's just there.
Wow.
It struck me as being very odd. I thought possibly it could be a reflection from the water, but on looking at the photograph in more detail, I realised it couldn't be, because the next photograph following on from there shows the same diagonal black mark, but the ship is at a different angle. She's moved.
This is a crucial thing.
And if you blow the image up even more, and particularly that area, you will see that the top part of that black diagonal mark follows the line of the hull plating.
Yeah.
Which is very, very strange.
And it just stops there, doesn't it? It just stops completely.
Exactly.
What you found is absolutely inexplicable. We were looking at the exact area where the iceberg struck, and we appeared to have a weakness or damage to the hull in that specific place before she even left Belfast.
If the Titanic had been weakened in the very region where it would be struck by an iceberg, it could rewrite history. But what could lie behind the mark? The photographs reminded Sennen of a fact known generally only to Titanic historians. The ship suffered a fire.
It instantaneously jumped into my mind that we had a fire in this location before she even left Belfast.
The fire took hold in a coal bunker in Boiler Room 6, and the room is directly behind the place where the dark mark begins.
The question is, once he knew he was approaching iceberg.
The fire was mentioned in the official inquiry in 1912, but was judged to have played no role in the disaster.
So I've always known about the fire, and yet people tend to treat it as an irrelevancy. I've seen other researchers who tend to discard it because this fire was played down.
This new evidence sent Sennen back to eyewitness accounts given by people on board. One description in particular, reported just days after the disaster in a New York newspaper, caught his eye.
I found an article by John Dilly, a fireman, who wasn't brought before the bench in London. He actually was speaking at the quayside to a journalist, and he said that, unlike an irrelevancy, the Titanic fire was very, very important.
John Dilly was one of a team of firemen and stokers who kept the hungry Titanic boilers fed with coal. Dilly describes a serious fire in one of the ship's huge coal storage bunkers. It was discovered the day the Titanic prepared to leave Belfast for Southampton and begin her maiden voyage. The procedure for coal bunker fires was to dig out the burning coal before the fire spread. But the Titanic was the biggest ship ever built. Her coal bunkers were 3 stories high.
He said, my sole duty, together with 11 other men. That's how many fought the fire. It's incredible. If you couldn't have an easily extinguished fire, that spoke to me of a very major fire. And this is what Dilly is saying. Listen to him. He says, there were hundreds of tons of coal
stored there. We made no headway against it.
4 days later, and the fire was getting worse.
But still, here is Dilly making serious claims about this fire. We didn't get that fire out.
From the day we sailed, the Titanic was on fire.
Dr. Guillermo Rain is one of only a handful of scientists specializing in the dynamics of coal fires.
This could definitely be because of smoldering fire.
Dr. Rain thinks it's likely that the coal fire started by itself and burned for some time before it was detected.
The scary part of smoldering coal is that it doesn't need an ignition event. It's spontaneous. It's what we call self-heating. It doesn't need an arsonist. It doesn't even need an accident. Just the bed of coal, the kernel of the bed will start to very slowly to heat up, but it will continue spreading until actually over the course of weeks,
Weeks?
Yeah. So when someone detects a smoldering fire in a big bed of coal, the fire has been going on for days for sure, weeks probably.
The fire was discovered the day the Titanic set sail from Belfast. But the coal had been loaded into its bunkers 3 weeks earlier. The coal was stacked directly against the hull and a watertight internal division called a bulkhead. Both were critical to the ship's strength. Exposing them to the extreme temperatures of a coal fire would have been incredibly dangerous.
The worst case scenario is it starts to affect severely the mechanical properties of the structure.
It's a design flaw.
It is a design flaw. Let's put it this way, I would not go into a ship that I know there is a smoldering fire inside.
Really?
No.
Bunker 10 held more than 100 tons of coal, only accessible via 2 hatches. The only way to deal with the fire was to shovel the burning coal into the engine furnaces.
So they were moving the coal around while it was on fire into the boilers. Yeah.
3 days into the voyage, Hendrickson and his team are still shoveling the burning coal.
It took us right up to the Saturday to get it out.
But once the coal was out, Hendrickson discovered evidence of the extreme temperature generated inside the bunker.
The bulkhead forms part of the bunker, the side. Yes, you could see
Where the bulkhead had been red hot.
Red hot. Yeah, this is incredible. This is one of the ship's major protections.
right.
And it's burning red hot. That seems to me like a very big deal indeed.
The steel wall that had taken the brunt of the fire was one of the Titanic's main bulkheads. The bulkheads divided the hull into separate watertight compartments. In the event of a breach in the hull, they stopped water flooding the entire ship. The Titanic was now just under 3 days from New York. This was one of the Titanic's first-class lounges. Only the wealthiest passengers on board enjoyed these luxurious salon suites. But as guests relaxed, on the bridge, Captain Edward Smith and White Star Chairman Bruce Ismay were receiving wireless warnings that icebergs were drifting into the ship's path. And although the burning coal in Bunker 6 had now been cleared, astonishing new evidence reveals that the red-hot bulkhead had caused the fire to spread.
I've come across an article in the New York Tribune from Saturday, April the 20th, 1912. The story was first told by an officer. He's saying the fire was in the coal bunkers, plural. Coal bunkers, not one. And this is giving accurate information. He says it was in stokeholds 9 and 10. Here we have evidence of spread into not one bunker, but two.
Firemen were now frantically clearing out a second bunker, throwing even more coal into the furnaces. Could this new information explain one of the greatest mysteries of the Titanic disaster? Inexplicably, despite the warnings, the Titanic maintained course and accelerated to top speed into the ice field. The Titanic wasn't trying to set a record time for a transatlantic crossing. She simply wasn't fast enough. So why did she hit top speed? A second fire, causing tons more burning coal to be emptied into her furnaces, could finally explain the mystery.
That huge amount of coal being transferred into the hungry furnaces faster than they would like. This is the impelling, driving force that is feeding into a ship. She's now at 22.5 knots, charging towards her destiny.
At 11:40 p.m., the Titanic collided with an iceberg. But it wasn't the ice alone that claimed the ship. In the last hours, the fire had one final deadly role to play in the disaster. 400 miles off the coast of Newfoundland, the Titanic struck an iceberg. The collision punctured the forward starboard side of the hull. But the bulkheads held firm, and a rescue vessel was not far away.
There was no reason why Titanic couldn't have lasted an hour and a half longer. Carpathia would have reached it and no one would have died.
The ship's designer clearly agreed. He assessed the damage and said the ship would not sink, but only if critical bulkheads held. What he did not know is that one of the bulkheads in question had been badly damaged. Buried in the transcripts of the American inquiry, Senon believes he has found the final event that triggered the ship's sudden sinking.
So the American inquiry was brilliant in that initial surge of enthusiasm in drawing out some key answers.
Lead fireman Fred Barrett had fought the coal bunker fire and was in Boiler Room 6 at the very moment when the ship hit the iceberg. As seawater flooded in, he took refuge behind the very bulkhead warped by the fire.
When I turn to the evidence of Fred Barrett, I'm further reinforced in my idea that something serious is happening here, and at a very crucial period.
Around 2 hours after the collision, Barrett says something drastically changed. He describes a torrent of water crashing through the fire-damaged bulkhead.
I saw a wave of green foam come tearing through between the boilers.
This breach sealed the ship's fate.
When that wall of steel goes, we have a series of tipping dominoes, and this is the critical failure that suddenly gives the upper hand to the ocean.
An academic study has shown that at this precise moment, the ship started to sink rapidly. Within 30 minutes, the chronometer on the bridge was beneath the waves.
Hi there. We have conducted experiments in my lab at Imperial. So what the bulkhead does is the hot part bulges. It's a significant bulge out.
Very noticeable.
The blue is that actually it bulges inwards. So it doesn't bulge all of it out, there is a part of it that bulges in.
So you get a buckling of the plate.
You have like a wave across the bulkhead.
This is the first time scientific analysis has been used to predict the extent of the damage caused by the fire. And it matches the eyewitness accounts from the Titanic firemen to a remarkable degree.
That is absolutely amazing, gentlemen, because I will tell you what was said in 1912 in this exact section we're talking about. The bottom of the watertight bulkhead was dinged aft, and the other part was dinged forward.
This is what you see here.
It's amazing, isn't it?
That's precisely what we are predicting.
According to the computer model, this type of warping only happens at very high temperatures. It confirms historic reports of the damage, and that the fire was far more significant than the inquiry suggested. The effect of the heat on the bulkhead steel would have been catastrophic.
The strength will change. How much it can resist cracking will change. It's going to be a quarter of the strength that it has at room temperature, which is why it deforms so much. So if you have a gradual build-up of water, the force on the steel is high enough to cause a crack, and then the brittleness of the steel means that crack spreads right across in a very catastrophic manner.
Wow, it went through.